Hello friends. So in this video we are going to have a discussion on uh, typecasting in C language. So what is typecasting? It is to convert a variable from one data type to the another data type. So there are a list of examples that is int to float, float to int, and there are various other examples which we will discuss in this session regarding the typecasting. So there are two types of typecasting. One is implicit typecasting, in which the typecasting is done by the compiler itself. And there is a explicit typecasting that is done by the programmer, avoid some of the warning and some undefined behaviors, as well as some cases like signed and unsigned. This will help us to avoid some errors that may occur if we don't enable this typecasting or we won't take it seriously. So let's start with the first example. In the first example, I will take a float value. Float a is equal to 10.5. Then I take an integer value b, and it will give this b the value of a, that is the float type, and we will try to print the value of p, percentage p, and we will check what will be the value of p. Save it and compile it. So for any conversion regarding warnings, we'll have this flag of GCC. So once we compile it, we'll have this warning: conversion from float to int may change value. So compiler is giving us a warning that we are trying to convert a float value into an integer value. Okay, so but the compiler already did this compilation, and we will have this binary. We'll test how it works. So if we have, so here the value of b will be 10, but the a value is 10.5. So we are eliminating dot 5 in this value, and we are printing only the base component. Okay, so in order to avoid this warning, we need to have explicit typecasting of this variable a, that is float, and we need to convert into the data type int. So if we put int here, then if we compile again, we won't get this warning. So this is for telling the compiler that we know, okay, this is float value and we are putting into this the integer value, and we need only the integer part of this float. So it's just for the readability, also for the compiler to let them understand, okay, we know this is a conversion that is happening. Okay, so let's take a second example. In this, I have a value int a is equal to 10, and b here will be float, and we are putting a into b, that is a float value, and the value of b should be a float value. So let's see what will be the output this time. So I again compile it. I again got a warning in which conversion from int to float may change value. So this compiler is warning me like this is happening. So if I compile this binary, but here we are getting 10.6 zeros, as we have percentage f here. If we want to round off to two digits after decimal, we need to have dot 2 here. And if I compile it again, and execute this binary, I'll get 10.00. Okay. So if we want to remove this warning again, what we have to do, we have to put a float before this, and we'll save this. And when I compile it again, I won't get any warning. And if I execute it, then I'll get the value as 10.00. That is the earlier value only, but without warning. Okay. So let's take one more example. So in this, I will take integer a is equal to 10, integer b is equal to 5. I think we should take 3. Okay, and we have a float value. Float c is equal to a divided by b. And here we will print the value of c up to 2 decimal, and we'll print c here. So let's see what will be the output of this program. So I again got a warning that there is a conversion from int to float. So in here, a is integer, b is integer. If we divide an integer with an integer, it will give you a integer value itself. Okay. So this integer value is been allotted to c, that is a float. That's why this warnings came into existence. But if we compile this binary again, we have 3.00, and this is not the right. If you divide 10 divided by 3, then we will have 3 dot something, right? 3 something. So how to do it with the explicit typecasting? So what we will do, as this is a float, so we'll take the value float here and we'll save it. Let's see what's the result now. Value that 3.33. Okay. Uh, let's take one more example so you can understand how the overflow of the data works. So let's remove this example, and I will take a unsigned. I think I'll take unsigned char x is equal to 0 cross ff00 plus, or we will take 0 cross 01. Okay. So if I see here, what will be the output of this? So if I have to print the value of x in binary format, then we have this. Okay, so let's compile it and see. So we again get a warning here. So what is this warning? So this is the hexadecimal representation of this value, and it is a 4-byte value, but our character x is only 1 byte. So they are saying this value is been overflooded, right? So we are converging a higher value into a lower value, right? So next value is 0 cross 01 only. So if we plus this value, let's see what will be the resultant. So we will get 0 cross 01. Okay. Why this is happening? Because this part of this variable is eliminated, and we'll get 00 only here. So resultant will be 0, and here this hexadecimal value, we have only 1 in the low octet. So here we will get the value as this 1. Okay. So what happens? if I take the one value or two value here, so the resultant should be 3, right? So because this got eliminated, still we have this value. Okay. So this will, add with this and it will give you 0, 0, 1, 1. That would be 3. So the value of x should be, so let's save it first. Okay. So the value is 3. So from here, we understand that the lower values can be converted into that smaller value as well, and vice versa. So depending on the explicit typecasting. So here, what we need to remove this warning as well by doing explicit typecasting. So unsigned conversion from int to unsigned character. Okay. So here we have to do the typecasting so that the value, and it's good for readability as well. So we'll give unsigned char here. We'll save it, and once we compile it, there will be no warning. So here we are telling the compiler as well as for readability point of view that this value, we know that this is going to be, heading into a unsigned character, and we are printing this value.